Hello everyone, myself Tejashree and my roll number is 2341A04B6. I am from first year ECE in SRIT College, Anantapur. Today I am going to explain the topic restriction on location of poles and zeros in driving point function from the subject network analysis and the subject code is 23 Here the question explain the restriction on location of poles and zeros in driving point function with suitable problem. Restriction on location of poles and zeros in driving point function. The location of poles and zeros in driving point function plays a crucial role in determining the stability and behavior of a system. The poles and zeros must satisfy certain restrictions to ensure the system's stability and performance. Understanding these restrictions is essential in the analysis and design of control systems. Definition of poles and zeros. Poles are the values of S for which the denominator of the transfer function becomes 0. Zeros are the values of S for which the numerator of the transfer function becomes 0. The poles and zeros of a system are crucial in determining its transient and steady state response. Stability analysis. For a system to be stable, all poles must have negative real parts. If any pole has a positive real part, the system will be unstable. The location of poles in the left half of the complex plane indicates a stability system. Relationship between poles and zeros. The number of poles must be greater than or equal to the number of zeros for a causal system. If the number of poles is less than the number of zeros, the system will be non-causal and physically unrealizable. The relative locations of poles and zeros affect the system's transient response and frequency characteristics. Dominant poles. Dominant poles are the poles that significantly affect the system's response. The dominant poles are usually located closer to the imaginary axis in the left half of the complex plane. Designing controllers to influence the dominant poles can improve the system's performance. Stability margin. The distance between the poles and the imaginary axis determines the stability margin of the system. Systems with poles closer to the imaginary axis have lower stability margins and are more prone to instability. Increasing the distance between poles and the imaginary axis can enhance the system's stability. Frequency response. The location of poles and zeros affects the frequency response of the system. Poles determine the resonant frequencies and bandwidth of the system. Zeros influence the system's high frequency behavior and can improve transient response. Here the problem statement. Consider a transfer function with a pole and at s is equals to -2 and a 0 at s is equals to -1. The system is stable as the pole has a negative real part. The relative location of the pole and 0 affects the system's response and frequency characteristics. Conclusion: the location of poles and zeros in the driving point function is critical for system stability and performance. Understanding the restrictions on pole and zero location is essential in control system analysis and design. Proper placement of poles and zeros can enhance system stability, transient response, and frequency characteristics. This is the video of poles and zeros. Thank you. Thank you for watching this video.